This is kind of where we were, right? All right, so there's our random hash function, right? It takes every key, maps it to an integer, and so when you have something to insert, you just hash it somewhere. You say, oh, where does 5 get hashed? It gets hashed there, right? Where does 9 get hashed, right? 9 gets hashed up there, so forth, right? So it's pretty straightforward, and so you can do it all in constant time. And then how do you search for something? You say, where's 5? Well, you follow, where does 5 get hashed? It gets hashed, there it is, right? So that's constant time. And now if you want to say who's after 5, well, it's just a mess here, right? There's just nothing there for you, right? Everybody good? Oh, and now collisions are a problem, right? So what we're doing is, we want to choose this hash function to randomize things, to avoid collisions. And we have to deal with collisions. And how are we going to choose our hash function? All right. So, so we do it at the beginning. Doesn't depend on, right? We do it before anything arrives, right? If you knew what keys were coming, right, then you could maybe be able to do fancier things, right? But we don't know what keys are coming, and that keys are going to come and go throughout the history anyway, right? So we're going to assume we don't know. Now, so if you take 1090 from me, which some of you do, you know this game about, right, the algorithm guy is choosing the hash function, and the adversary is choosing the input. What's the input is which keys come. And it clearly, if you choose the hash function first, then what inputs are going to come is adversarially, everybody's going to get hashed to the same cell, right? You're just going to say, hey, there's some cell that lots and lots of things go to, and that's all the keys that are going to come are going to go to the same cell, right? Everybody see that that's not fair, right? So where do they go? Oops, well, some collisions. We want few collisions. Oh, but worst case collisions. What are the worst case collisions? Is we get inputs and they all go to the same cell, right? So if we want our algorithm to work well on every input, right? Then how do we prove it works well on every input? Is we get an adversary give us the worst case input. And what is the worst case input? They all go to the same place, right? So how do we deal with that? Right, so here, for example, the hash, we could hash to the last digit, right? Why not? But then it could be that it turns out that all the last digits are the same, or it's what, right? If the input was random, then that might be fine, right? But if, we don't know what random inputs look like, right? How can we say the input's random? We don't know the distribution on inputs. So we shy away from saying the input's random, right? Because certainly the worst case is that the last digits are all the same, right? And then they all collide, right? Everybody kind of following this? These are things we're thinking about, right? So now you might ask, is the world really adversarial, right? I write a piece of code. Does the universe come and study my code and give me the input that's really worst case for my code? Probably not, right? Right, though it sure is looking that way when you look at politics these days, right? All right. So in order to confuse this whole thing, we do randomness, all right?